In this video, we're going to add, multiply, and divide with square roots. Now, when we add and subtract with square roots, it's a lot like combining like terms. We'll simplify each term if possible, and if the radical terms are the same, we'll combine the coefficients and attach the radical term. So 9 square roots of 5 plus 2 square roots of 5 equals 11 square roots of 5. We're adding two terms that had square root of 5, so all we had to do is add the coefficients. It's a lot like adding 9x plus 2x. That equals 11x. So here we have negative 8 square root of 2 plus 7 square root of 2. They have the same square root, so we'll just do negative 8 plus 7 is negative 1, and we attach the square root. Now the 1 there looks a little funny, so let's go ahead and just rewrite that as negative square root of 2. Now these square roots are different, but maybe we can simplify this 250 so we end up with a square root of 10. Well, 250 equals 25 times 10, and 25 is a perfect square root. So I think we're onto something here. So we're going to break this down and rewrite it as 8 times the square root of 25 times the square root of 10. Let me just write minus 8 square root of 10. So I rewrote the square root of 250 as the square root of 25 times the square root of 10. Now that's helpful because the square root of 25 is a perfect square root. It's just equal to 5. So let's rewrite this again here as 8 times 5 times the square root of 10. We're still subtracting 8 square root of 10. So now we can just multiply 8 times 5. And 40 square root of 10 minus 8 square root of 10 equals 32 square root of 10. Once again, we do not have common square roots here, but maybe, just maybe, we can simplify the square root of 50 so that we end up with the square root of 2. Well, once again, we'll use the square root of 25, as 25 times 2 is 50. So I'm going to rewrite this as negative 7 times the square root of 25 times the square root of 2. Let me just put minus 3 square root of 2 here. So the square root of 25 times the square root of 2 is the square root of 50. So I just broke down that 50. Now, once again, the square root of 25 is a perfect square root, so this will be negative 7 times 5 times the square root of 2. So we end up with negative 35 times the square root of 2 minus 3 times the square root of 2. So I just multiplied 7 times 5 there. And negative 35 minus 3 would be negative 38. And we still have the square root of 2. So adding and subtracting with square roots is a lot like combining like terms. Now multiplying square roots is different. We're just multiplying. So if there are any coefficients in front, we multiply those. And we multiply the square roots together and simplify if possible. So the square root of 3 times the square root of 2 would just equal the square root of 6. And the square root of 7 times the square root of 5, well, that's just equal to the square root of 35. Now when we're dividing by a square root in a simple fraction like these, really all we need to do is rationalize the denominator and get rid of the square root in the denominator, and then simplify. So to get rid of the square root in the denominator, we just multiply the numerator and denominator by that square root, and the square root ends up getting moved to the numerator. So let's multiply the top and the bottom by the square root of 3. And when we multiply two fractions, we multiply across the top and multiply across the bottom. Now the square root of 3 times the square root of 3, that equals the square root of 9. which equals 3. And that will always happen, and that's why we did this. We wanted to get rid of the square root in the denominator, so we multiplied by that square root, and that gets rid of the square root every time. And we don't cancel out these 3's because that 3 in the numerator isn't really a 3. It's the square root of 3. So here we have a square root in the denominator. So let's go ahead and multiply the top and bottom by the square root of 11. Multiply across the top. Multiply across the bottom. And now we no longer have square roots in the denominator. Okay, I hope these examples have been helpful. This is Mr. Ela, signing off.